Right now we're going to do 3.6, which is solving quadratics using the quadratic formula. This is the classwork you should have from the sub, so if you have this, you are good to go. First thing we want to do is just this warm-up, and what we want to do with that warm-up is just graph it with at least 5 points, and then make sure the x-intercepts are 2 of the 5 points. So pause the video and do that, and then resume it when you're done. All right, so if you finish this one, get my iPad out. But, graph and provide a table of values. So, I'll make a quick table over here with x's and y's. So we got our x's and our y's. So the key is here, you got to get the vertex, right? The vertex is the most critical part of the parabola. So that has to be on there. And then you can base other points around that. So, if you're going to do the vertex, you're going to probably want to do negative b over 2a. So we're going to go negative 6 over 2 times a is 2. So that's negative 6/4, which is the same thing as negative 3/2. Right? So that's the x-coordinate of the vertex, which is where we're going to put it over there. And then we need the y-coordinate just by plugging it in. So when we plug it in, we're going to get 2 times negative 3/2 squared plus 6 times negative 3/2 minus 8. And then negative 3/2 squared is just going to be 9/4. So times 2 would make it from 9/4 to just 9/2. 9/2 minus, this is going to be 18/2, which is double the first one. And then minus another 16/2, which gives us 9 minus 18 is negative 9, minus another 16 is negative 25 half. So like negative 12.5. So negative 25 halves. So if I look at the graph, the graph that I have, I'm probably going to want to go by 2's just so that I can fit it on there. So we can go by 2's. This needs 2, so negative 2. All right, so negative 1.5. I'll still go by 1's on the x-axis. So negative 1.5, and then negative 2, 4, 6, 8, 10, 12, and then 12.5. So there's the vertex. If you want to get other points, certainly the y-intercept is easy. So that's going to be plugging in 0, and you'll get negative 8. So 0, and then 2, 4, 6, 8. And if you think about your axis of symmetry, you're 1.5 to the right, you can go 1.5 to the left, and then negative 3 would give you the same thing as 0. So we got negative 3, negative 8. Oops. Negative 3, negative 8. Now you just need 2 more points, and it asks you for the x-intercepts, so you can get the x-intercepts, which honestly you could just factor it. They both have a 2 in common. So if I pulled out a 2, that would leave me with x squared plus 3x minus 4. Which would factor into x minus 1 and x plus 4. So your 2 zeros from that would be negative 4, 2, 3, 4, and positive 1. And then your graph would just be those all connected. All right, and then we're done with the warm-up. Now, the part of the lesson is really the quadratic formula, which we've seen before. Negative b plus or minus the square root of b squared minus 4ac, and then all over 2a. So that takes the a, b, and c values from standard form. So if it's not in standard form, you have to put it in standard form to do this. So if we took these same a, b, and c values and plugged it into this, we should have an idea of what we would get. So, if we plug it in, negative b is going to be negative 6. plus or minus the square root of b squared, so negative 6 squared, minus 4a, which is 2, and c, which is negative 8. All over 2 times a, which is 2 again. So if I was to keep going with this, I would have negative 6 plus or minus. Negative 6 squared is 36. And then minus 4ac. So minus 4 times 2 is 8. 8 times negative 8 is going to be negative 64. So it's going to turn into plus 64 all over 4. Oops. 4. And if we kept going with this, 36 and 64 is 100. And the square root of 100 is 10. And that's still over 4. So you get your two answers, but you don't want to leave it like this. You can keep going with these. So negative 6 plus 10 over 4, and negative 6 minus 10 over 4. Right? Negative 6 plus 10 is 4. 4 divided by 4 is 1. And negative 6 minus 10 is negative 16 over 4, which is negative 4. So what are you solving for? What is the quadratic formula solving for? Right? It's solving for the zeros. It's solving for the x-intercepts if they're real. So what if we factored first? Well, we already did factor first, right? And this is what we got. 2 times x minus 1, x plus 4. So that's what I'll do here. It's 2 times, I'll do it quicker this way, x minus 1, x plus 4, which if you set it equal to 0, right, you could divide both sides by 2 to get rid of the 2, and you would get x equals 1 and x equals negative 4 that way. So it's a different way to get zeros and roots and all that other good stuff. Besides factoring, you can also use a quadratic, and sometimes it's better. Obviously, factoring would have been quicker here, but not everything is factorable. Some things are prime, meaning they're not factorable, so the quadratic formula will always get you those answers. All right, so if we look at the quadratic formula, right, I kind of want you to try and answer these questions on your own and just think about them for a second and then resume the video after you've answered them. So do that throughout the whole video. But basically, what does it solve for in an equation, right? So pause the video and then resume when you think you have an answer. Okay, so hopefully you've answered both of these, but what does it solve for? If it's an equation, meaning like ax squared plus bx plus c equals 0, right? This is an equation. What are you solving for? Right, it's solving for the values of x that make it equal to 0, right? Which is just answers or solutions. You could also say roots and zeros too, but really, I mean, you're just like it would just say solve this, and you'd have some numbers in for a and b and c, but those are your answers, right? Whatever you get if it's equal to 0. Now, if it's a graph, meaning if instead of it's 0, it's equal to y or f of x, then all of a sudden it's not an equation that can be solved, right? It's just y is equal to this thing. You know, if you're looking for roots and zeros, then you set it equal to 0. But you know, if it's just equal to y, what does it solve for on a graph? Well, it's the x-intercepts, right? That's what it's looking for in a graph. Now, that would have to be if they're real. If they're not real, then it's also, you know, roots and zeros. So I'll put that in there too. But just keep in mind that, you know, they're not answers if it's equal to y. There's not an equation that can be solved. It's just more of finding characteristics of a graph if it's equal to y or f of x. If it's equal to 0, then they're answers and solutions. You just solve it. Okay. Again, you can answer these questions 3 and 4 and then pause it as you try and answer them and then resume it when you're done. All right, if you think about why it has a plus and minus sign, well, the first thing is it has a degree of 2, right? All quadratics have a degree of 2, meaning that's just the highest exponent. So if it's a degree of 2, then when you're solving it, right, or if you're finding the x-intercept, you should always have 2 answers. So why does it have a plus and minus? Well, it's going to give you both answers. The x, there should be two x's, right? So I'm going to put degree of 2 gives you two answers. Or if it's a graph, right, if it's equal to y, then it'll be two x-intercepts, so two zeros, two roots. So, obviously when you plug it in, when you plug all these things in, you need to have two answers since it's degree of 2. Well, the plus and the minus allows for two answers. It's like we did in the warm-up. It's negative b plus this over 2a, and it's negative b minus this over 2a. Those will give you your two answers, right? So how many answers does it give? 2. All right, 5 and 6, you can pause that and then keep going. Okay, so number 5, can it give you imaginary answers? Yes, right? If b squared minus 4ac ended up being a negative, right? If the answer was negative just from in here, you would have a negative sign under the square root, which you would pull out with an I, right? So can it give you imaginary answers? Yes. And then how many would it give you? It would give you 2, just like any other thing. It would give you negative b plus I root something over 2a and negative b minus I root something over 2a. So it could give you 2 imaginary answers for sure. And then what would that look like on a graph if you had an imaginary answer? So if you're setting it equal to 0, whatever those answers are, whatever results here are your answers. But if it's y, you can't really have imaginary x-intercepts. So that's where you don't actually have any x-intercepts. You still have zeros and roots, but you just can't see them on a graph. So on a graph, it could look like a couple different things. That's not what I wanted to hit. But basically, if you had a graph, really simple, it could look like this, where it opens up and the vertex is above the x-axis, which just means it never actually has any x-intercepts. Or it could open down and the vertex is below the x-axis, meaning it never actually intersects the x-axis. So these two parabolas don't have any x-intercepts, but they still have two zeros, or they still have two roots, however you want to phrase it. That's the difference between an x-intercept and a root. If it crosses, they're x-intercepts and roots and zeros, they all mean the same thing. But if it doesn't cross, you can't technically call it an x-intercept anymore because it's not intersecting the x-axis. So there's still roots and zeros, they're imaginary, and those would be the answers you would get as a result of doing this. You could get imaginary answers, yeah. All right, and then last but not least, we have these two questions. Actually, not last, second to last. So pause the video and answer them. Okay. I think of this. Can you give you one answer? And the answer is yes, technically. Technically, I would say it's still 2, but if you think about b squared minus 4ac, right, you can have negative b plus that number and negative b minus that number, right? So if you have negative b plus 2 and negative b minus 2, those are going to give you two different answers. However, if b squared minus 4ac was 0, you would have negative b plus 0 and negative b minus 0, which is the exact same thing, right? If you add 0 to something or subtract 0 from something, it's the same thing. So it is possible that if b squared minus 4ac was 0, you could have only one answer, or one x-intercept, or one root, or 1 0. Right, so yes, if b squared minus 4ac equaled 0. And then what would that look like on a graph? So how could you draw a parabola that only has one x-intercept? And if you think about it, you could have it, and I think we've talked about this before, where it could be a parabola that opens down and the vertex is on the x-axis, which would look something like that. It could open up as well and have the bottom touch of it, but that has only intersects the x-axis once, whatever that point is, and that is what we call a point of tangency. And then I also said technically it is still two answers. That value of x right there, right, whatever value that was, is it creates a point of tangency, but we would say that value of x is technically a double root, which means that number is actually a root twice. It would factor into something like x plus 3. In this case, maybe x plus 1 times x plus 1, so negative 1 is a root twice. That's what happens when you get a point of tangency. That number is a root twice. So technically, you could argue that it's still two answers, just the same answer twice. But really, it's only one unique number. It's one different number. And if b squared minus 4ac gives you 0, then that's what you get. All right, last two. So pause the video and answer these two. Okay, what part decides how many solutions and zeros and what type they will be? So if we've kind of answered all these questions, we've found that we can get one answer if b squared minus 4ac is 0. We would get two imaginary answers if it's a negative number. And then, of course, you'd get two real answers if this was positive, right? Negative b plus 2, negative b minus 2, those are all real numbers, and it would be two different numbers. So this b squared minus 4ac is the part that's determining how many solutions you're going to have, either one or two, and what type they will be. Are they going to be imaginary? Are they going to be real? You know, one or the other. So that is the part that we're looking at to determine all of that stuff. So that is called the b squared minus 4ac. And again, if it's positive, two answers, they're all real. If it's negative, you still have two answers, but it's a negative underneath, so you have to pull out with I, so two imaginary answers. And if it's equal to 0, then really only have one unique answer, right? Again, we'd say it's a double root, but it's just one number. And then what do we call that part? Here's your vocab term for the day. That is called the discriminant, right? Because it basically discriminates the types of answers that you're going to get and how many you have. So b squared minus 4ac is it's called the discriminant, right? Those are one and the same. So basically, all I want you guys to do to finish out the rest of class is do these 6 questions. Tell me how many solutions, you know, if it's an equation, right? This is a graph, so, you know, how many zeros it would have. Or if it's an equation like this one, how many solutions it has, right? So again, that's the difference. This one has a y or f of x. This one's just an equation, right? This is another graph, so that would be, you're talking about zeros or roots. These ones you're talking about answers or solutions because there's no y, right? You'd just be solving them. So tell me how many solutions it has, or zeros if it's a graph. Tell me what type, just meaning are they real or are they imaginary? And then C, actually go ahead and find the actual solutions for all of them. So you can work in groups of 3, you know, figure out who's done with the video at this point and group up and then do these 6 questions. When you finish, you can resume this video. I'm just going to pretty much give you the answers and then that'll be it. Okay, so if you did number 1, you know, you can do b squared minus 4ac. I think it comes out to be 28. So the fact that the discriminant is positive tells you that there is 2 solutions and that they are both real since it's positive. So 2 real solutions. And then I think if you went ahead and found them, like doing the whole quadratic formula, it would reduce to negative 3 plus or minus root 7. So that's the first one. The second one we'll do, and this one, if you got it all, you know, I'd move the 12a over to make it equal to 0. And then when you did it that way, I think you get a negative discriminant. It would be 144 b squared minus 4ac, which would be 160. So it'll give you negative 16. But the fact that it's a negative discriminant tells you that you still have 2 answers, 2 solutions, but they are both imaginary. And then if you went ahead and solved them, I think it came out to 16i, so which root 16, which negative root 16, which is 4i. So negative 12 plus or minus 4i over 10, which they all have 2 in common, should reduce to negative 6 plus and minus 2i over 5. Number 3, if you did this one out, b squared minus 4ac, I think came out to be 7. So that tells you that's a positive number. There's 2 real solutions. So 2 real. And if you actually did them out, I think you would get 3 and 5/4 as the 2 actual zeros or solutions. Which just the fact that these are rational numbers just means that you could have factored it to begin with, but that's okay. You can use the quadratic formula anyways. Number 4 would give you 0 as the discriminant. B squared minus 4ac is 0, so that one would be an example where you only have one 0 or one x-intercept, and that has to be a real. You can't have one imaginary, that's impossible. So it's one real solution. It would actually just be considered a double root. You'd have a point of tangency, and that point is actually at x equals, I think, -1/2. So that would be that answer. Next one. This is another example, I think, if I'm not mistaken, where you would get 0 as a discriminant. It would be like 100/9 minus 100/9. So this is another one where you have one real solution, and then the actual solution would be -1/3. So one real and -1/3. Now keep in mind each of these last two, actually last 3, you had all rational answers, which just means they all could have been factored. And then last but not least, we have this one. Now with the root 6, I'm not going to, it's okay if you didn't find it. But you could do b squared minus 4ac, and you would get 49 minus 12 root 6, which, root 6 you can ballpark, but 12 root 6 is definitely going to be less than 49. So you're going to have 49 minus a smaller number, which would leave you with a positive result. So that just tells you there's 2 real solutions. And that's it. You don't have to actually find it for that one. So that's it. Slides are done. You guys can start the homework if you're done, and there's still class time left.